everybody, my name is Yassine Banwar. I'm a PhD student in last CNRS lab in Toulouse, France. The purpose of today's presentation is to talk about the OM2M platform, which is an extensible and standardized platform for the M2M interoperability. I will divide my talk into these parts. I will begin an introduction to explain what is Internet of Things, machine-to-machine concept. Then I will present the standard proposed by the European Telecommunications Standards Institute for the machine-to-machine concept. After that, I will present the OM2M platform. Then I will present some scenarios for subscribe notify mechanism, and I will finish my talk by a conclusion. Let's begin by the concept of Internet of Things and machine-to-machine. In the web, users have become more numerous. This user is no longer just a consumer of data, but also he interacts with by adding some information in the web. So we can say that the web upgraded from static to dynamic to reach the web 3.0, which includes not only human but also machines, things, some devices. One of the main concepts of Internet of Things is called machine-to-machine concept. It can be defined as the combination of information, technologies, and communication in order to provide the possibility to these machines to interact between them without any human intervention. However, M2M is suffering from a vertical fragmentation. It means that for each constructor, we can find a dedicated application with its dedicated API to interact with the dedicated device domain. To overcome this fragmentation, the European Telecommunications Standards Institute proposes a horizontal architecture platform with an application infrastructure to offer to these applications a kind of uniform or standardized API to interact with the devices. Here is the architecture proposed by the ETSI for the M2M concept. First of all, we have our server. Then we have we call them ETSI devices that they can implement this service capability layer. After that, we have some devices called M2M legacy devices that they can't interact with the server, and they need a gateway for that. The ETSI M2M provides service capability layer. It's kind of a set of common functionalities and service capabilities we have. For instance, for NA, for network application, if it wants to interact with for instance, with legacy devices, it uses the API offered by the application enablement. It can retrieve the data from the reachability, addressing, and repository service capability. It can also use the generic communication to communicate with the gateway, or use the interworking proxy, which provides some mechanism to interact with the devices or legacy devices. Okay, let's talk now about the OM2M platform. This platform is provided with the purpose to improve M2M interoperability by implementing the ETSI M2M standard. It offers a RESTful API, meaning a unique URI such as http, www.nsl.com, for instance. So, and using CRUD methods. CRUD methods, it means create, read, update, and delete, for instance. It uses also a set of simple service primitives such as SAS discovery. It can allow to the gateway to discover the server and vice versa. Also, registration for these components. It allows to manage access rights for users and manage also the resources. Okay, let me begin by the first demonstration and the first kind of interesting things. Here is the demonstration. We have our machines that can be a laptop. We will go through the wired area network to reach the server in last NRS. Then we have LAN. Here is our server. We have LAN to communicate with the microcontroller. That is our gateway. And we have also the Phidgets hub, which is plugged some sensors and actuators. Okay, here we have, for instance, lamp. We have also fan, and we have some sensors here. We can, for instance, I will show you the request. Using just this URI, for instance, to turn on the lamp. We can also use the same URI to turn off the lamp. Maybe you will ask me from where I get this URI for the lamp, because ETSI proposes a resource structure for to represent all the information or resources. We have here all our applications such as sensors for temperature, humidity, luminosity, and we have the actuators, lamp and fan. Here we have some containers and the descriptor where we can find some buttons to turn on or off the lamp. We can get this information or URI using this from this description of the actuator. We can do the same thing with our fan. Okay, here is the OM2M component diagram. We have some components sorry if it's not. We have some components responsible on communication protocols such as HTTP or CoAP, and we have some IPU to communicate with devices such as Zigbee devices or Phidgets devices, which is wired technology. We have also the main component, which is the core that allows to have the request from the communication protocols and then routes it to the different resource controllers. This platform is our platform is very extensible. It offers some interfaces such as REST client service with this method. Also, we have the core allow to also interfacing with other plugins by offering the SL service interface. And for the IPU, if you are a technology provider, we have just to implement these 5 methods: do create, do retrieve, do update, do execute, and do delete to interact with the platform. For the implementation, OM2M is running on the top of an OSGi Equinox layer, making it highly extensible via plugins. It provides a flexible SL that can be deployed in the M2M network, a gateway, or device, as I said before. Each SL is composed of small, tightly coupled plugins. Each plugin, as we can say, we have some plugins for the core, for the communication protocols, HTTP, CoAP, that we already implemented, MQTT, not yet. We have also for the Zigbee, for the Phidgets, for some protocols used for device management, such as mobiles. And we implemented also the TLS for the security issue. Okay, here is a simple interoperability example related to the IPU for some technologies. The user has just to send to the core a technology independent request to our model. It's responsible on mapping this technology independent request to specific technology requests and send it to the node. The node will answer and send this response to the same model, which is responsible on mapping this specific request to a generic or protocol independent request and forward it to the core. Right now, as I said, we implement one for the Phidgets and another one for the Zigbee, and it's extensible for any other technology. For the communication protocol mapping, we have, here is another interoperability example. We are a user or HTTP user. I will send an HTTP request. It will be received by HTTP mapping. It is responsible on mapping this specific request to a protocol independent request. For instance, we have, for the methods, we have get, it will be mapped to retrieve. We have post to create, put to delete. It's a protocol independent request and forward it to the core. After handling this request by the core, it will send a protocol independent response, and the same component will be responsible on mapping this response from a protocol independent response to a specific response to our requester. We implemented also in our platform and plugin responsible on CoAP mapping, which is a communication protocol dedicated for small computing devices, such as gateway or this kind of it's a kind of microcontrollers. And it's also extensible for any other communication protocol. For the communication techniques, we have defined three kind of techniques. First of all, we have the request response. It's synchronous. Also, we have a long polling with the client, which is server enabled, and we have subscribe notify. I will explain it. For instance, we are a network application. I will send a request by creating this resource to be notified for each SCL or service capability layer, remote service capability layer creation. After the registration of the remote gateway and creating this resource, the network application will be notified for the creation of this new resource. Okay, here is a more complex scenario. Okay, I'm a network application. What I want is to monitor remotely the lamps changes, for instance, and keep a history in the NSL. This kind of communication, it's not possible between the network application and directly to the gateway. So we have these interfaces. What we can do is to first of the things is to create a content instances in the NSL for lamps data. Then the user can subscribe to the subscribe to this content instances. Also, the NSL will subscribe to the data lamps data. When lamps will create its new state, it will send a notification to our server, and our server will notify the final user. Okay, let's go then to the next demonstration. I will make two demonstrations. The first one is about group management, how we can switch a group of lamps, a set of lamps together. For this, we have our server, which is here. It's this machine, and by a LAN network, we will communicate to the BeagleBone Black, which is this microcontroller. and to monitor and to turn on or off some lamps that are here using a hub with for Phidget technologies. Okay, here we are in the resource tree for, I said before that we will disturb some colleagues, so it's confirmed right now. Here is the resource tree of our server, which is this machine. Now I will go to the gateway. I have no application because I didn't plug yet my Phidget. Okay. Here is all my plugins. I will start the Phidget responsible on the plugin responsible on the Phidget communication. It is 24, I think. Yes. Okay. Now, when I plugged my my Phidget hub, it discovers all the equipments. We have some sensors, or just one, and three outputs for the lamps. I have the same table, and I can maybe if I can control. You can see. Okay, it's good. I can turn on or off the lamps remotely. I can create some new applications if I want, using the URI and the representation of the new resource. I can also specify the group of my lamps that I want to turn on in the same time. Here I have 4 lamps for output 0, 1, 2, and 3. I have just to send a post with the URI and the empty body. Oh, sorry. Here I could turn them all on, for instance. Okay, the second scenario is related to the subscribe notify technique, and for that I will use the lamp which is in last. Here on the left, I have my application, which is subscribed to any lamp change for the stage. For instance, if I toggle the lamp, it will receive a notification that the lamp is turning on for, sorry. Okay. Here, I have the same room, and we have here on the left the application, which is subscribed to receive notification for each lamp change state. For instance, if using my mobile phone, I can change the state of the lamp, and this application will receive the notification that the lamp is changing from true to false. Then if I can remotely monitor any changes of my house lamp, for instance. Okay, it was also thanks for your attention, and now if you have any question, I will be very happy to answer them. Thank you.
On one of the earlier slides, you actually used the quantity weight. Is that the official ETSI term? Because that's not really...
Which one?
You use some actuators or various sensors. You didn't demonstrate it, but you had a list of luminosity and weight, yes, and all sorts of things. And I was wondering, is that how ETSI officially calls it? Because that's not the metric term. So it was one of the slides much earlier.
Okay. Which one?
When you had the lamp, and then you had some actuators showing.
Okay, it was not this one, no. This one?
Why is 003 called weight? The official SI
no,
term is actually mass. So do you call it like that? Or
yes, we call it like that. We were free to choose the name that we want, but which is important here is to follow this, we can call it tree representation of the resources. We have in these resources some collections with the fixed names, and some others that for which we can choose the name that we want.
Yeah.
Here,
in this case, 003 would not comply with the actual SI or metric quantity for that, because that's called mass. If you call it like that, and if you're not exchanging that information with others, then I guess you should be fine. I was just curious if that was something that ETSI called like that, because then I would have been a little puzzled.
No, ETSI gives free to choose the name that we want for these resources, application resources. It's under the applications collection. But we don't have to change the name of the collections. If you see what I mean. For instance, applications, it's a fixed name. We don't have to change it. We can choose, for instance, the name of the route, GSL, which is the identifier of the gateway. Okay. We have also this, this representation of data. ETSI said that we can use, not ETSI, but we used a kind of OBX for this data representation. It's based on XML files. We have some information about the sensor, such as the type, the ID of the application, the data of and the unit and location of our sensor. Yeah.
The unit is also used. There are some other Eclipse projects that allow you to verify the unit or convert it to others.
Yeah. Yes.
So I noticed that you had your HTTP-based commands. You had obviously get post, but I also saw you had a command called execute. Can you explain how that's used?
Actually, sorry, execute.
Yeah.
Execute is for HTTP. It's mapped in HTTP to a post with empty body. Execute is, for instance, if you want to control some actuators to turn them on or off, you need to use the execute method, which is for, as I said, for HTTP is a post with an empty body. And it's used to, as I said, to control lamps or fans or.
So why do you use that compared just with, say, doing a straight post or value?
What?
Value could be low.
What?
So why do you choose that approach as opposed to just a straightforward post with?
It was defined like that. For in the standard, they said for a post with empty body, it will be mapped into execute for our inside the platform.
It's kind of special.
No, it's not. It was specified in the standard that for a post with empty body, it's an execute, and it's used to, as I say, to control some components. Any other question? Maybe. I think that it's all, and thank you for your attention. Thanks.